Let's get started in proper then. My name is Glenn Condren. Thank you for being here. I'm a program manager on the ASP.NET team. Specifically, I work on the ASP.NET core runtime, right? I work on the DNX. I work on things like dependency injection, configuration, logging, all these core underlying parts that MVC and those web frameworks and stuff sit on top of. Okay? I work pretty closely with some folks on the CLR team to be able to make sure they have the CLR bits together, things like that. If you want to reach me, I realize that I don't have my thing here, but it's at CondrenG on Twitter, or Glenn C with 2 N's at Microsoft.com. I'll warn you that I think I have 3,000 unread emails right now and no unread tweets. So you can decide which of those two methods you want to use to contact me with. I probably read the subjects of most of them. Maybe. Okay. If Damien Edwards, if you're watching this talk, I'm sorry, I do have a slide in a deep dive. I know you'll be disappointed, but I thought it made sense. But we're not going to begin there. We're going to jump straight over to some code, and we'll start looking at some demos. So, first thing, you can all see the code. What this is I call this little sample hello web, okay? This is basically file new empty web project. And then with a startup CS and a project JSON and nothing else. So this is basically the smallest kind of viable web application you can build on top of ASP.NET 5. What I've added to this thing is I added the diagnostics NuGet package, Microsoft.ASP.NET.diagnostics. I've added a console logger, and I've said use welcome page. All right? Now, what that means is that if we jump into this command line here, and we go dnx.web, like this, whoop. I get an error. How many of you have tried ASP.NET and seen this before? 2, 3, fantastic. Okay, when this happens, there's a few command line tools. I'm going to start introducing these to you straight away instead of running this thing in Visual Studio first. The first one that you will ever hit probably is dnvm. Okay? dnvm, the .NET version manager, is the thing that will go and download DNXs and put them on your machine. We're going to get into lots of depth of what the DNX is. For now, DNX is the thing that the runtime that sits underneath all of your web applications. It's what hosts them, okay, for the most part. It's kind of an umbrella term because there's lots of bits inside the thing DNX. And it's a package that sits on NuGet, has lots of assemblies in it. And logically, we often group a few things that aren't actually in that package under the umbrella term as well, like hosting. So we'll get into lots of that. So the first thing I'm going to do is go dnvm list. What this tells me is I have a heap of different DNXs on here. I've got a bunch of beta 4s. They've got different runtimes, different bitnesses. It tells me where they are on my local machine. You can see all these guys are in my user profile. But I've got no stars here in this active column. Okay, that's great. So I can go dnvm use any of these version numbers that I've got in this version column. Over here in this alias column, I have a default. I can basically use these aliases on this right-hand column are just shortcuts to whatever the version is that they're sitting in. So I can go here, dnvm use default. And then it says something here, which is adding the beta 4 bin to process path. How many of you are already familiar with your path environment variable? Hopefully a few of you. Good. Okay. This is adding. There's a folder, this path, C users, Glenn C, DNX runtimes. Inside there is a couple of X's. All this dnvm tool is a glorified path manipulator and downloader. Okay? It does some HTTP requests, it grabs some DNXs, downloads them off of NuGet, and it manipulates your path so that where they're downloaded on disk is on your path, so that when you go DNX, it runs the right thing. That's all it does. Okay? It's not rocket science. Rocket science, yeah. Okay, so let's clear and go DNX. Now I've got a DNX. Fantastic. Now I can go dnx.web. And now what I'm really saying here is run this DNX thing. Now the reason DNX didn't work is because this DNX is an exe sitting inside that path from the DNX package that we just added a thing to our path that has DNX exe in it. And then I'm saying I'm going to pass 2 parameter arguments. This is just a console app, DNX. I'm passing a dot and I'm passing a web. Dot means this folder, and that variable is where my project JSON is, where my project is. Because I'm in the folder, it's a dot, this folder. And web is a command that we'll look at in depth later, which is inside my project JSON. So basically this is saying DNX, run the project that is in this folder, go to look at the project JSON, find the web command and do whatever it tells you to do, please. Okay? And in this case, when I hit enter, it runs and it tells me it's listening on localhost 5000. For those of you who have tried this or watched demos previously here that don't see any output here, that's because you haven't wired up logging yet. So that when I said factory.add console logger, there was now a console logger. Now I can see output when I run, and one of those things that's always output is informational in where we're binding to. Okay? So, now presumably we can go localhost 5000 and I can get a welcome page. Fantastic. I'm a little bit disappointed. This welcome page, you used to be able to click it and it would like drag down and like make faces. Then we realized that having like a big chunk of jQuery and JavaScript in this really tiny little package probably wasn't the best idea, and it should just be a static page. So that's what it is. And I hit enter just then in order to close down my DNX web and stop. Okay, so I have a hello web application. You saw me run it. This is the very skimming stuff that you've probably seen in talks before. I assume most or all of you all the people who watched the talks before, you've seen that before, right? Fantastic. Don't worry, it goes further. Okay? Now, the next thing we're going to do is we're going to publish something. From the command line, of course. We can't do things from Visual Studio, it'll be too easy. Now, we're going to use this command called DNU. How many of you saw DNU in previous talks? Any? A few? A couple. Okay, good. Now we're getting into some unknown territory. That's great. Okay, we're going to go DNU and we're going to say publish. And we're going to say I want to publish it to this folder. It's going to be C code/output ignite. Yeah? Ignite? Okay. And then we're going to say that's it. Publish. Great. Done something. Presumably done it really fast, probably slower because I had to do all that console output. So let's go over to that folder and see what it looks like. I have my code folder open, I have an output folder, I have ignite, and I have this thing. I have a few things here. I have an app root, I have a dub root, I have a web thing, apparently it's a nothing, and I have a web.cmd. Are there Mac and Linux users around? There's one. A Mac with a Visual Studio logo on it. That's what I like to see. This is a bash file, a shell script. So this and the CMD file is a batch file. Now there's an interesting thing we're going to diverge into for a minute, just to make sure you got that DNVM story. If I double click this, it should run my app, right? Yes? Yes? No. Okay. Why? Okay, let's start up a command prompt. Let's find out why. This is my more advanced command prompt. Yeah, it looks a lot better than my other one, right? See? Okay, we're going to paste this into here. And we're going to say, we have the right thing, right? Yeah, web, go. Oh. This looks familiar, doesn't it? Okay, when you go DNVM use, you're only manipulating the path for the console that you've got running right now, which is this window. Right? So it's only this exact command line window that you're seeing here that has a DNX on its path. It's not on my whole machine, it's just this shell. Okay? So on that other console window, there is no DNX because I haven't manipulated my user level path or my machine level path, only the process path. You've got 3 levels, right? So I can't just double click on a thing. In DNVM, what you can do is go DNVM use default, and you can say -p for persist. Now you can see some output. It says process path and user path. So now I've manipulated not only have I set this console's path to default, I've also set it at the user level, which means all of the consoles that I ever start up should inherit that same path. It's not going to work here because I started this command line before I'd modified it. So I'd have to restart this shell to make it work. Okay? Theoretically now, when I double-click the batch file, my app runs. Okay? So, what am I doing here when I double-click this batch file? Now you understand something about paths. And it is just paths, just environment variables, like normal Windows environment variables. And when I talk about environment variables in the context of configuration, if I get to that, they're environment variables as well, normal Windows environment variables. Okay, so what did we just do? We just ran our app. And this is where everybody says to you, look, I've got a magic self-contained application. This is fantastic. It's beautiful, right? No, not in this case. So, what do we have here? And I'll show you why this one isn't self-contained. We'll talk about it. Who saw the Visual Studio publish, where they do publish in Visual Studio? Publish to file system or publish to Azure or any of those? There's a few people, good. That runs this command line, okay? So when you go publish, do that through that dialog, this command line that we're exploring right now, it's automating that. So you're looking at the under the covers bit of what Visual Studio does, okay? When we said we want to make a cross-platform experience, the easiest way to do that is make a command line experience and have tooling automate the command line, and then things start to get a bit better. Okay, so what we're going to do is look into this folder structure. That's what we're going to do. I have an app root and a www root. Okay, I'm going to open up this webcmd in a minute, show you what's in it, and we'll talk about that. But inside my app root, I have packages. This is every NuGet package that my application depended on. There's a lot in here, even though I don't have much in my actual application, because if you remember, with NuGet packages depend on other NuGet packages, depend on other NuGet packages, so you can end up with a pretty deep hierarchy pretty quick. So there's lots of NuGet packages, even though I explicitly only depend on a few. There's lots of transitive dependencies, right? Okay, so let's go into here. We have an app root. We have a packages folder. There's lots of packages in here, all the NuGet packages I depend on. There's a source folder. Inside the source folder is the source code for my application. It's fantastic. This is possibly the demo you see where people are like, look, I can deploy source code on my server. Yes! And then probably everybody in this room freaks out about putting source code on their server, yeah? Fantastic. Why don't you want to put source code on your server? That seems like a great idea. Okay. So let's talk about the next command. I want to show you this quick command because this is the question everybody asks. First, we're going to delete everything from here. All right? I'm going to come back into here. We're going to do publish again. This time I'm going to go --no-source. And now, see that build succeeded output? Now we should see something different over here. Now if I open my app root, I have only packages. There is no source folder. Okay, because I haven't packaged my source this time. I said no source, so clearly that means I don't want any source. In here I have this package, which is new. It's called Hello Web. Hello Web is the name of my application. So what's happened when you said no source is you've gotten a NuGet package for your application. The NuGet package is in here, but it's also exploded, so you have the DLLs for your application, and they can be loaded and they can be run. Okay, you'll get Project JSON in here. Okay, we've got a bunch of stuff. We've got stuff in here. Okay, I don't have any MVC in this application, but you would see like views and stuff in here. Like your views aren't necessarily compiled as part of that step unless you opt into that in MVC, but pre-compiling your views. But okay, so that's my app root. So now I've got an app root. It has all my packages and it has my compiled application inside of it. Sweet. Now I'm self-contained, right? Everything is good. So let's have a quick look at web.cmd. Okay, this is what it's doing. It's running dnx.exe. Now, based upon what we just did with path and double-clicking this thing, what has to happen in order for this to actually work on the server? Sorry, someone actually answered. Yeah? It's got to be on my path. Exactly. So this thing is not going to run on its own. There has to be a DNX somewhere on the machine that is on this thing's path. This type of packaging is assuming that when I get to the server, there's going to be a DNX there already. And that someone is going to have set it up. Probably your friendly neighborhood IT guy, I guess. Your server admin, maybe. Somebody. probably yourself when you're running on your dev machine at least. Now, we'll dig into that in a second. So actually, let's look at it now. The other thing it does is it passes this application host and this web thing. We're going to look into those in more detail too later. And this is an argument we use, which is just telling us where the application is. So this will be different depending on whether you've compiled source or not, because it'll point to different places inside that app package. It gets generated every time you do a publish. Okay, so let's try a different publish. First thing I'm going to do is go dnvm list. Then I'm going to say dnu publish. The next command that you're going to want to know is this one, which is runtime. And I'm going to put 1.0.0-beta4. This is going to fail. The reason it's going to fail is because you can't just give dnu publish a version name. It's not quite smart enough to take a version name and work out the folder path. And the hint to this is, if you look at this thing here, this C uses, this is your hint path. I can't find this 1.0.0-beta4 you're talking about. The places I looked were, for some reason, 1.0.0-beta4 in the exact folder that I'm in. And then I went and looked in your runtimes folder on user profile for a thing called 1.0.0-beta4. Okay, so I have my runtimes folder open here. If you look at it, nothing in here is called 1.0.0-beta4, right? The folder names are all significantly more complicated than that. They've got to start with DNX, CLR, blah, blah. So what this DNU is basically doing is just a dumb copy almost. It knows a little bit about where to look for runtimes, but you have to give it the full name. So if we say, okay, I want this name, this one looks like the right one for me, I'm going to do that over here. Let's do this again, and let's paste this guy in and go publish. Okay, we've built our application again, we've got our runtime, everything should be good. Now let's have a quick look in here to see what's different. Now I have a dnx.clr.win. Fantastic, okay, we're getting closer, right? Closer and closer to this mythical self-contained application that you guys have heard so much about, that you had all those questions about, right? Let's look inside WebCMD. Okay, this is different now. Look at this. Now, instead of just saying run dnxexe, it's saying go into the folder that's inside this app root and run the dnxexe that I just put inside your application, and then pass all those other things to it. Okay? So now we're self-contained, right? This is a leading question. The answer is no. Okay. We are not self-contained. The reason we're not self-contained is because of this guy. It's a CLR DNX, right? And CLR, the two switches we use for .NET 4.5x and Core CLR is CLR and Core CLR. This is a CLR DNX, which means it runs .NET 4.5x. And as you probably all know, you need to install the .NET 4.5.6 on your machine, right? Or 4.5.1 or 4.5, you know, one of the 4.5x's. So this is self-contained in that it only uses what is in this folder and the .NET framework that's installed on Windows. Okay, that's what this is. And we know from this that it's Windows specific. Keep looking at the wrong machine. It is Windows specific, and we know it's 32-bit, right? Because this is the x86 one. If we wanted the 64-bit DNX, we'd replace this with 64 here, right? And we'd get the 64 one. Okay, makes sense? Okay, so the next thing I'm going to talk about is one of the things that we talk about occasionally is I want to publish this app to Linux and Windows. So from my, if I clear this and go back to my dnvm list, I also have this guy, 1.0.0-beta4 mono. Okay, it doesn't have an architecture, which is interesting. We'll talk about why later, and it's in the same place. Now, if I go back to my runtimes folder, the folder name for the mono one is here. See? So let's copy that. Go back to my command line, do our publish. I'm just going to add another runtime command. Okay. Now, when we zoom in here, it says somewhere here, where does it say it? Bundling runtime DNX core CLR win x86. Bundling runtime DNX mono 1.0.0-beta4. Fantastic. So now when we go over to our Ignite app and we look in our app root, we have both. And we can run on either of these guys. They're the same version. They're the DNX. Our application runs on the DNX. One's mono, one is CLR, and we know mono runs on Linux. And if you actually look in here, it even has, like bash, it even has different versions of DNX and DNU that are going to be for your Windows or your Linux or your Mac. Unfortunately, however, this little web.bash file, we're going to have a look at this guy. This one, okay, thank you. This one still, both the webcmd and the bash file, they're both going to just point to whatever the first runtime is you asked for. It's not smart enough to kind of work out that one's not Windows and one is. So if you wanted to have this app kind of running the exact same published app, you can have one run on Linux and run it on Windows. You'd probably come in here and edit this guy to point to the mono. This is just a file path, so it's not complicated. Point it at mono instead, and then you'd be able to run this bash script on Linux and Mac, and you'd be able to run the batch file on Windows. Does that make sense? Yeah, making sense? Fantastic. Okay. Now, that's the one last thing that we're going to look at about this folder structure. I wanted to dig into this first to help you give context for the DNX kind of deep overview that we go through in a second. I also had a bunch of questions about this, so I'm going to go a quick talk about it. Inside the www root, over here in my Hello Web application, I don't have anything in my www root. Are you guys familiar with the www root? There's nods and hands. www root is where you put static content and stuff. All right? So there's nothing in it over here, but I do have something in it over here in my packed output. I've got a web config. And for those of there's probably a bunch of you out there are going, wait a minute, I remember this talk and we said there was no web configs around anymore. There is web configs. They're for IIS for the most part. You can actually put application settings in here if you want. We do have a configuration source that will point to like an XML, I think, actually. I could be wrong about that, so I'm not going to say we do. I might be lying. Pretty sure we have one that can point to web config. If not, someone I'm sure will make it at some point. We can certainly point at an XML file. So inside our web config, we also have this bin, and it has this ASP.NET.loader DLL. What these two things are for is if you take this folder and you go into IIS and you create a web application and you point it at the www root, that is how you make this run on IIS. Okay? Inside IIS, and you leave all the configuration of IIS assumes that your application is just a current MVC, like ASP.NET application. IIS doesn't actually know anything inherently about ASP.NET 5. It's this web config file and the thing inside that bin that gets you into ASP.NET 5 land. Okay, this is Helios. This is the first part of the duality of Helios. So I'm going to talk about what that means in a second, but this is where you point your web application. Okay, I had a lot of people ask me that question because you only ever see like command line demos or IIS Express, and there was some confusion. Hopefully that helps it out. Maybe yes, maybe no. Huh? Multiple webs in the same thing? You mean you would have a single published output for this. You would point it here, I think. But ask me again at the end, so I actually get the details of your question. So. Ignite. There, so that's that. So now you kind of understand all of how you get an app ready to go to a machine, right? That's good, because if you want to actually deploy something in the near future, you probably need to explain that to a few people, right? The other reason I wanted to show you that, other than having lots of questions about it and giving you that understanding, is that I'm about to talk about what the DNX is. And I wanted to do this first so that you had a little bit more context when I started to talk about some of the things in this next slide. So this is my slide, which is the DNX structure. If you want to play along in the audience, if you go to github.com/ASP.NET/home, in the wiki, there's a page called DNX structure, and it has a picture that looks remarkably similar to this slide. They may or may not have come from the same Visio page. Okay, in the beginning there is native code. There is a process that runs your application. When you're on IIS, IIS manages that process. You probably all know what that process is called even, right? Yeah, there's a native process. So, and then it's managing your process and it's taking care of making sure that that native process has a CLR loaded and all that sort of stuff. Inside that bin, in .NET 4.5.1, we added a hook. into .NET 4.5, into the .NET framework, that said, when you're booting an ASP.NET application, look inside that application. If there's a bin folder, and it has that ASP.NET loaded assembly that we saw, and it adheres to the contract, if it is a Helios assembly effectively, give control to that assembly, and let it take care of loading the rest of the application. Right? This was the beginnings of our experiments of how to oob, or move ASP.NET out of the .NET framework. So that's the escape hatch that we're using to be able to take this package and run it on a server, even if that server knows nothing about ASP.NET 5. Back in our published sample, I didn't add a core CLR DNX, but if I added a core CLR DNX, it would have had the exact same effect in that the DNX batch file would have just pointed to a DNX exe in there. The difference would be that there's a CLR DLL in there, which is the CLR that's running. So in that world, if you take a package and if you take your app and it's got a DNX Core 50 target and you publish it, package it with DNX Core and you move it to a server, that server just pretends that it's an ASP.NET, normal ASP.NET application. The server doesn't need to know and doesn't have to know that you're publishing an ASP.NET 5 application. It'll work without that. So if it takes a long time to get new things installed on the machine, for example, or something, or if you want to try it out straight away, you don't need to do anything to the place you're pushing it to right now, because Core CLR is self-contained, as long as you've got at least 4.5.1 where we added that hook to make Helios work. In the future, there'll be a native module. This says /native module. Sometime in the future, there'll be a native thing. You can install it on the machine, and then you'll actually get options in drop-downs in IIS to say Core CLR. Right? But for now, Helios is your way to do this. Does that make sense? Some more nods. Fantastic. There's a lot of people that had questions about that. Next is DNX exe and other platform-specific exes. So DNX exe is this thing that we were looking at. That's where you're like running it in the command line, or other platform-specific executable is just the same thing on Linux or Mac. It's a DNX exe, right? And we're going to talk about this. In fact, I'm going to do something a little bit special. Hopefully you guys enjoy it. I'm going to run dnx-debug.web. And now my application says, oh, process ID 7204 for some reason, and waiting for debugger to attach. Fantastic. Okay, I just happen, as if I knew this moment would come, to have the DNX source code on my machine. This was cloned from GitHub. Now, what I'm going to do is I'm going to go debug, and I'm going to go attach to process. I'm going to find DNX in this little window here. And it was 7204, right? So I need 7204 here in the ID window. You see that? If you're going to try this at home, make sure you've got both managed and native selected up here if you want to do exactly what I'm about to do. You need both. And they won't necessarily be selected by default. Then I'm going to go attach. Okay, load some stuff. And then hit a breakpoint. Okay? And the breakpoint that it is eventually going to hit, maybe Visual Studio hasn't taken me directly there for some reason, is here in dnx.cpp. So, oh no, look, there's no symbols loaded. That's unfortunate. Does anybody have any idea why that might be? Nope, okay. Huh? I did enable native debugging, but that was a very good guess. Okay, DNVM list. The DNVM that I'm running is 1.0 beta 4. It's downloaded from NuGet and it's in my runtimes folder. The other thing that I have over here, though, is this thing called 1.0.0-dev. So what these are, whoa, that was the wrong button. What these things are is when you clone the DNX repo, it has a build batch file. You can run build, and you can run build dev-install. And what that does is over here in my runtimes folder, see these ones that have little shortcut icons, like little desktop shortcut icons on their folders? These are symlinks. What these are folders in my runtime that actually point to where the source code of DNX is. Right? So if I go dnvm use one of those dev ones, as far as everything is concerned, I'm just running a runtime that's in my runtimes folder. But really, it's the one that I built on my local machine. So the problem I have here is I'm not running the same thing that what my source code is in the thing. So if I go dnvm use dev, because I've got an alias called dev, and I change this changes just my shell process path for now to the one that I've got built locally. And then I run this. Now it's 5128. Remember that? Because I might forget. Then I go debug, attach to process, DNX. Which one is it? 5128. Luckily, it seems to always be the first one, which is fantastic. Oh, now look. Look. I have a little yellow thing. And I can look at stuff. I can say stuff. Looks fantastic. Are there any C++ developers in the audience? This probably means more to you than me then. But think about what we just did. Okay, look at this thing here. This is the call stack. Look at what's underneath us in the call stack. Right? Underneath us is kernel32.dll. Right? We just downloaded the source code from the internet, and we are stepping into the bottommost layer of this running this web application. There is nothing that you cannot, well, almost nothing that you cannot step through and look at and see what this stuff is about. So in this case, we're running this is still actually CLR, so we're running the CLR, but this C++ code you're looking at right here is that DNX-exe that we just looked at. It's the native process. This is the console app that runs your web application. Okay, we're going to step in here. Now, in IIS, obviously the console app is something in IIS, but the next bit of native code we get to in a minute, Helios still uses that. I think that bit, yeah. So let's have a look at what this call process main method does, which is all that main method, that thing did. What this is doing is saying, there's this thing here, pwz host module name. This is a DLL name. It's dnx.clr.dll or dnx.coreclr.so or blah, blah, okay? So this low-level DNX-exe is the same whether I'm doing, it's the same if I'm core CLR or 64 or 32-bit. It's just cross-compiled, so we just build it a bunch of times, get a bunch of different binaries. And that's why you need all those flavors of the DNX, because you've got this native bit at the bottom of the stack, and that stuff is architecture-specific. You need a 64-bit build and a 32-bit build and all that sort of stuff, right? So you've got flavors of the DNX, and they all have slight differences and if-defs and stuff to handle differences in the way that platform works. But all this thing is doing is it's going to load that DLL, whatever one it was told to load, and it's going to call its main. And we're going to press F11 and step down. And then we found this thing called Katana Manager, which is interesting given that this has nothing to do with Katana. So now where we are is we're here in this core CLR native host. Not core CLR native host, it's the Net45X native host. But we're in a native host. So that bottom layer, its job is to give you a process. Either IIS gives you a process or DNX-exe gives you a process. Now, we've got some native code. This next bit of native code is responsible for giving you a CLR. Something has to load the CLR into your process. In your .NET world today, the thing that loads the CLR into your process is something baked into Windows or something done for you magically. You get an exe, that exe you double-click does stuff for you to load the CLR into the process and then execute your code. There's a whole bunch of magic that happened. That's what this bit of code does. And we can kind of look at it if we really want to. So if we switch back, if we step down here, this initialize runtime method in this Katana Manager, if we step into this, oh, we won't step into it, we'll just look at it. This calls a bunch of stuff, none of which makes any sense to me, but it looks fantastic. It makes me seem much smarter when I pretend like I know what it says. Eventually it says runtime host.start. All these methods are documented on MSDN. If you really want to know, go for it. Somebody will know what they do, I'm sure. But effectively these methods are what is loading the CLR and getting it into my process so we can run manage code. Then down here we say call application main. This isn't actually your application main, it's the next stack up the next layer up in this diagram. We're about to go back to the slide and go up and I'll show you. But there's one thing. So this is the end of the native bit. Okay, this application main here is where we start to go to managed. And we'll switch back to our slides so that we can talk about that. Now, there's this bit right over to the right here, and I'm sure, given that everybody put their hand up with their developers, that it's kind of been bugging you that this box is empty this whole time, right? So, we will fill it with mono. We don't control mono. For Core CLR and Net45X, we have this DNX here, and we have this native host. Mono already has all that stuff. So, the DNX for mono, it just calls mono. It says, mono, go do whatever you do. I'm sure it does something very similar to what we just looked at. Okay? So that's the way that the mono thing works. You can actually look at that. If we go up in the DNX, if we get time later, we can look in the DNX. If inside the DNX that's inside the mono one is just a bash file, and inside the bash file it says DNX run. Sorry, it says mono run. Right? So it assumes that there's a mono installed on your machine. Okay? Now, the next bit of the stack up is manage code. Now I may understand something about the code that I'm going to look at. It's going to be fantastic. So, the managed entry point is the next bit. The managed entry point's job, now we've got the CLR. It's time to start doing some stuff. And the stuff we're going to do is we're going to begin the loader chain, and we're going to start kicking off some DI stuff. And basically, at this point, what happens is each of these layers, you know how it said call application main? Each of these layers in this stack diagram is just a series of, you know, when you create a console application, you have a program.cs that's got a main in there, a main method. Each one of these layers doesn't know anything about the layer above it. Often, it doesn't even know its name. It just knows that there's something passed to it on the command line, right? And so these are just calling the main method of the thing above them over and over again, and they're all like almost completely independent of each other. So the managed entry point is the last point where we know about the name. Application host is kind of different, and we'll talk about it in a second. First, let's switch over back to our diving, spelunking through the code. What I'm going to do here is I'm going to press F11. Okay, and look, this code looks great. C#. I know something about C#. This is amazing. And then think about for a second what we just did. We just said, I'm going to put a breakpoint where there's nothing underneath me except operating system code. And then I'm just going to step through until I hit C#. And if I want to now, I can keep going until I hit my startup CS. And I can look at all the code in the middle. That's amazing. Right? There's people that often ask us, what is the best? Sometimes people ask us, what is the benefit of doing open source software development? Okay? Now, the other benefit of this is, if you run --debug and you attach it to your web app and there's an error happening somewhere in here, you can see the exception being thrown. And you could go log a bug on GitHub saying, hey, this line of code is failing. And I'm sure some developer will appreciate it. Okay. Here's something that's cool we're doing. We're spinning up this socket on a background thread for no apparent reason. That comment there says it's for perf, so I'll believe it. So you're going to start seeing some interesting things that happen here. So this is inside this managed entry point. I just skipped a whole bunch of code. I pressed F5 because there's a whole bunch of stuff that happens. It's not really important or interesting. A lot of command line argument playing and stuff like that. This is the next interesting thing that happens, which is I set up this loader container. I have this thing called a load context, and I add this thing called a path-based assembly loader. I'm going to describe these three pieces really quickly, and then we'll probably start to surface out of this Splunk. So the load container holds loaders, funnily enough, who would have thought. The loaders are how we resolve assemblies in DNX. So when you have a project JSON and it has a name, like Microsoft.asp.net.host.something, logging, we ask the loader chain, tell me how I can get an assembly that matches this thing, right? And the loader chain does it. There's a NuGet loader that knows how to load NuGet packages. There's a path-based assembly loader, this one, which knows how to load assemblies from your DNX folder. Right? The loader chain is how the magic of dropping some source code into your app and having it switch to source code instead of the assemblies works. The last thing that we're going to switch to is this DNX, this load context, and this line here in particular, which is appdomain.currentDomain.assemblyResolve. Whoa. And we're basically binding this event. That means that this is how the DNX takes over loading assemblies from the CLR. Because it doesn't really take over, not in .NET. Some of you may have hit this event before. This event is whenever the CLR doesn't know how to resolve an assembly, it fires this event and says, and then we take over and say, well, I think we got it. It's over here in this NuGet package. If the reason I wanted to show you this line is because if you're on .NET 4.5.6, you have the GAC. Assemblies that are in the GAC just get resolved. This thing never fires. So if you've got something in the GAC in .NET 4.5.6, an assembly that your application is depending on, that's the one that's going to get used when you're running on the .NET 4.5.6, not regardless of what's in your application. Because the GAC is the GAC, and that's the way .NET works. In Core CLR, it's different. We have a lot more control over the thing that we can load, and we can basically say, we're going to take over everything, don't worry about it. Promise that we'll give you all the assemblies that you need. Okay? So that's that. So let's stop this now. Let's switch back to some slides, some conceptual, just a few more layers on top of this. So managed entry point was where we started to set some things up. Our application host and our design time host are interesting. The design time host is where in Visual Studio and in Visual Studio Code and in Sublime and Vim and Emacs, they can get IntelliSense for C#. Part of the way they do that is effectively via like a design time host process, which is basically a thing running a DNX in the background to your editor, compiling your app, giving you errors, giving you IntelliSense, giving you all this stuff. Okay? And that's what the design time host is for. So OmniSharp does this, right? And in Visual Studio it's the same. The application host is interesting. The reason it's interesting, it gives you the NuGet loader and the project loader, and it's where most of the stuff that you kind of know and familiar about ASP.NET 5 comes from. However, if we come and look at our application that we packaged earlier, actually let's do it in here. If we look in our project JSON, this is Microsoft.ASP.NET hosting. If we look in here in our web.cmd that we had earlier, the first parameter that we passed to DNX-XC is Microsoft.framework.application host. That's how the DNX knows what the application host is that name. If you get a DLL and it has a program name and you call DNX-XC and you give it that DLL name, it'll run it, or try to. Right? So there's no magic about how the application gets loaded. The application host loads, right? Okay. And then on top of that sits your application. So you can have an application sitting on application host. And then there's ASP.NET hosting. We just saw that in the web command. So once again, that's just a DLL with a main entry point. And when application host is done doing its thing, it calls it. Okay? And then you've got an application. Okay? This is there endeth. You didn't. I was switched over to the wrong thing. Pretend you saw me flick through these slides. There endeth the slides. So, we've talked about application host. We've talked about the whole DNX stack. Fantastic. Okay? Hopefully that gave you like an awesome 400 deep dive down into the bowels of the DNX and you understand conceptually what this DNX thing is now. Yeah? Some nods? Hopefully that's good. That's kind of what the intent was. Okay, there's some other stuff. Inside that hosting DLL, that's really where web-specific stuff starts to happen. Now, I'm going to kind of step back a little bit from the DNX for a little while now. One of the things that the hosting DLL does, it doesn't just call a main, it calls configure. It calls a couple of configures, actually. It calls configure services, and it calls configure. Two different methods you can have inside your startup CS. Is everybody familiar with these two methods? Vaguely? There's a few nods. Okay. So inside configure services, you can configure the service collection that DI is going to use. And inside the configure method, you configure the pipeline that the HTTP requests are going to go through. Okay? So what we're going to look at now is I'm going to do something else which is kind of amazing that we can do this. And what I'm going to do is say c/code/ASP.NET/hosting/src. Save. You've probably seen this demo before. Over here, and now I have some source code magically in here. All right, this is me switching. Before I was depending on this hosting NuGet package. Now I'm depending on this hosting source code. Looks like doing it has broken my references thing up here, probably because of a lock file or something, so I'm going to just touch this guy and make it do a restore, and hopefully that'll fix everything. So now, instead of running against the hosting NuGet package, I'm running against the hosting source code. And that's interesting. And the reason that that's interesting is if we jump over here into this program.cs, and we go down here into program main, I've got a breakpoint I prepared earlier. If I press F5, then I hit a breakpoint. So now I can actually step through the hosting assembly. This is a lot easier than trying to step through like native crap down on the bottom of the stack, right? I can just pull in the little bit that I need to care about. So one of the things that I want to quickly look at in here is this hosting engine. Now this does a bunch of stuff. One of the things it does is in the start method, which is what basically gets called inside the program main that this thing runs, it does a thing called ensure application services. This happens first. So configure services gets called first. It gets a service provider back. And then it passes that thing into this thing which says ensure application delegate. That application delegate is your configure method. Right? Then what it says is down here, these 3 lines of code here, that is where the HTTP context gets created. And where it gets passed through your configure, all your middleware. Who's familiar with middleware? Okay? So when you go app.use inside your startup CS, what you're doing is saying, get a class and add it to a collection of components, and those classes are called middleware. Over here, I have the diagnostics middleware to give you an idea of what this stuff is. So this is the welcome page middleware, which is, when I said use welcome page, what happens is this, sorry, I flicked really quickly then, my apologies. When I say use welcome page, what happens is this diagnostics class, which I've got open in a different solution, gets added to like a list, basically. When you do that, when back this code that we just saw over here, this hosting code, when it creates a HTTP context, it passes it through all of the classes that you add to your application builder in here. Which means eventually what's going to happen is the HTTP context we just say get created is going to get passed to this, right? To this invoke method. And it's going to do something. In this case, what it does is it returns this welcome page, which gives you this welcome, that's what displays that page. And then it calls next. So the way this thing works is, in order that you add them, they chain together. So when you add one at the top, it gets added, and then it knows about what the next one down is, and then it calls it at the end, and they call each other until you get to the end. So what you've got is this pipeline of little classes. HTTP context gets created when a request comes in, goes through the chain. Eventually something stops calling next and returns something. And then it comes all the way back, and you get a response, hopefully. Something happens. Depends on what's in the middleware. Does that kind of vaguely make sense? Okay, so let's think a little bit about what we just did. We looked at native code right on top of the OS. We stepped through into a bunch of stuff, all the way through our stack. We've seen code effectively from everything from the OS through to code that knows about web and knows about HTTP context and passes it and starts talking to our application. And you can look at it all. You could edit it, you could tweak it, you could break on exception. It's amazing. So most of you in your day-to-day job probably don't have to do any of the stuff that we just did, pulling in any of that source code. The key takeaway, I said I would give some key takeaways of the bits that with all the stuff we just did, for those of you who kind of got a little bit lost in the codes, is it's just code. Someone has to write it. And it's the same, there's a team just like your team that writes all of this stuff that's down here. You can debug it. You can look at it. You can understand it if you want to put the effort in to understand it. If you want to know why something is happening, you can walk all the way through the stack and work out why something is happening. You don't have to, but you can. And the other thing is the other reason for all of that was to give you a little bit of a mental model, which is for configure and configure services gets called first. It creates a collection of things, classes, types, stuff. And then a configure method gets called. It gets given the services that you put in configure services. It builds a collection of classes together, and then a HTTP context gets created and it gets passed through that chain. Okay? This is like the fundamentals of the way ASP.NET 5 and if you're using Katana and Owen in current MVC, how that works there as well. Make sense? This stuff, some of you probably have heard the terms Owen and Katana. That like middleware concept comes from Owen and Katana. Owen is an open kind of community effort that talks about building a HTTP pipeline in a way similar to what we talked about. However, they don't have a strongly typed like HTTP context. And many of the people who are really big Owen believers believe that there shouldn't be a strongly typed HTTP context. You shouldn't be able to go context dot user dot or whatever, all the stuff, all the strongly typed methods we've got that you can access information about your request and your response on. So because we have one of those, we're not really like Owen in terms of we have all the same concept, many of the same concepts, but we have all these typed objects. However, we support Owen in that you can pass the Owen abstraction in, which is basically a func of like dictionary of string. In that world, everything is just a string, a key pair, string key value pairs, and it's just a dictionary of key value pairs that flow through the pipeline instead of a strongly typed object. That's basically it. If I'm wrong, I'm sure somebody will tell me, but that is my understanding of the difference. Okay. Now, configure services gives me stuff. You've seen the demos where I add something into my services collection here, and then I accept it in my controller, and then everything is happy. Like suddenly I magically have this type over there. Yes? No? Yes? Okay. So in here, if I register anything, if I go like services.add, and I add something, or I add, say, singleton, which will mean there's only ever one of this thing that I add. And then over in my controller, in MVC, or anywhere in my DNX application, really, I accept that type. The DI framework will take care of giving it to you. So you get dependency, you get ISC, right? One thing that we often say, but we never really show people how to do, is that you can use other IOC containers. We kind of have one built in. We have this iService provider abstraction, which is like the bare minimum of how to do IOC. So what we're going to do pretty quickly is I'm going to add a dependency here to Microsoft.framework.dependency injection not dependency injection .autofac. Yeah, autofac sounds great. I'm going to say beta 4. Okay, and that added a dependency to autofac, not to autofac, well, it did indirectly. It added a dependency to basically a bridge, which is between the autofac IOC container and like the iService provider that we provide as our abstraction. And then inside startup CS, okay, remember what configure services did. Configure services gets a collection of stuff that our application needs, and then it gives it back to the hosting, so hosting can use it later on, and it can give it to the rest of the stack. So we want to do that, but we want to use our IOC container. So the first thing we do is we create in autofac, the autofac container is called a container builder. So you do container builder. This is an autofac type, not an ASP.NET type. Okay. Now, use me some autofac. That was just adding a using statement for me. Now, that's all great. We've got a container builder. Down here, we can go like container builder register to register some types with autofac. That's the way autofac works. If you use ninject or something like that, you pull in the ninject adapter package, you'll be able to use your ninject as a kernel, I think, in here. Like whatever the type for your IOC container is, that's how you register, is with whatever IOC container you're talking about. Now you'll notice though that there's these little yellow exclamation marks next to all of these methods. That seems somewhat concerning. And the reason for that is that it looks like autofac doesn't work on core CLR yet. Okay, that's all right. We don't really need core CLR today anyway. So I'm going to go into my project JSON, and I'm going to say, so the fact that I've got both of these frameworks here means that my application is always trying to build for both of them and run, and so that it can run on both of them. If I remove one of them, then I'm only going to run on .NET 4.5x now. See, I have no core CLR over there. And when I come back to my startup CS, I should stop this thing from running, right? So think about that for a second. I just had it running with a debugger attached the whole time I was doing all of those changes and it didn't break. Okay, so now if I go over here to Container Builder, I can do stuff. I don't have yellow exclamation marks because these types actually work on all of the target platforms that I have. That's great. Another option, you could have in here maybe said on core CLR, I'll just use the fallback container. And you could have maybe said, you know, hash if DNX 451. Same as the string that's inside Project JSON. Same thing here. And then only the stuff inside this if would only run when you're on that platform, and everything in the else would run in the other. So you could kind of if-defing your code to handle differences. And if you do that, you know, the code that's not running gets grayed out and stuff. So I think there's been some demos about that, so I'm not going to go into heaps more depth about it. The next thing you do when you're using this IRC container is go container builder.build, right? To say build me a container. Okay, now I have a container, and it has all the types for my app. Over here, up here, I'm like register stuff. Register awesome stuff, right? Because all of us write awesome code. Tomorrow we'll write awesome code, and today we write awesome code. Yesterday, we don't know what we were thinking. So the container has all the services that I've just registered for my app, and I'm going to go, but how, you might have been able to work out going this far on your own, but how do I get them back to hosting? Right? I haven't done anything to manipulate the service collection, and normally here you would just go add on that service collection and then hosting would take it and do stuff. So we're not going to do that here. Instead, what we're doing is we're going to return an iService provider from this method. Okay? And we're going to say return container dot. No, we're not going to say. We're going to say autofac autofac spelled without an uppercase L, registration. Apparently I really like to miscapitalize. Here is a type that comes from our actual bridge, right? And in here we're going to say autofac registration dot populate. Okay? We're going to give it the builder. We're going to give it the we're going to give it the container builder. And we're going to give it the and we're going to say container. And we're going to give it the service collection that we got in, right? I believe. Give it one of these types. Services, not service collection. Right? And then I think this is actually container. Maybe. Maybe I'm just completely wrong. I forget how to do this. My apologies. Oh, not return. And then, so sorry I got this order wrong. Complete mental blank. My apologies, everybody. Return container dot resolve, right? And then you want to resolve an iService provider. Okay, so what we've done here is a few things, and we'll talk about it now that I've actually remembered what I was talking about. Container builder, autofac type. That's the thing you register stuff with. Register some stuff. Populate takes any services that we got from the lower levels inside the runtime, like application environment gets created way down in the managed entry point. It knows about the OS and stuff you're on. So populate grabs all of those types, it registers them all with the same container builder that we just gave it. Okay, then we say build container, and then we say container, give me an iService provider. And inside that bridge code, there's an implementation of iService provider which uses the autofac container. So from here on out, every iService provider in all of ASP.NET, everywhere, is using the container that you just registered, not the one that comes with the stack. The one that comes with the stack isn't real good. You should use you should use a different one, probably. And when I say it's not real good, I mean it's feature poor. It only really supports constructor injection and scoping and a few really small features that we had to have the minimum amount that we could use to keep our developers happy when building the stack. So if you want like property injection, you need another container that does property injection. You're not going to get that. And then everywhere else in the stack, when people use the iService provider to start resolving things, whatever rules you define in here is going to start coming to play. Does that make sense? For those of you who don't know anything about IOC, doesn't really matter. At some point, you may need to start looking at it. This will make sense. All right? If you don't really care about it at all, in here you're just going to go services.add.mvc, and then down there you're going to go app.use.mvc, and you're never going to care about any of this stuff. Yeah. Does it support MEF? We only have a couple of bridges written right now, and I don't think MEF is one of them. We do have like a project ready to go to put all the MEF support in. I just don't think we've quite got to it yet. In fact, I don't think these packages for this bridge is actually on NuGet.org itself yet, potentially. They may only be on our MyGet feeds because we're kind of working with the people who own the containers to work out where the code should live and all that sort of stuff. Okay, so that's service providers and how you would register your own container with our stack. One of the things that we often leave out of our talks. Okay, this goes for 15 minutes more, right? Excellent. Okay, so the next thing that I want to talk about, we're kind of going to jump, I'm going to jump back to a different solution, and I'm going to open up this Hello Starter Web solution. Now what this Hello Starter Web solution is, it's just file new. Ah, look at this. This is great. Has anybody seen this error yet? Okay, that's good. What this error means is that in here in your global JSON, you can have a version of the DNX that Visual Studio will try and use when you're starting up your app. If it's set to something and Visual Studio can't use that one, you'll get that error at the start. Okay, so I want it to be beta 4 because clearly last time I was using this, I had some version of DNX on here. If I go DNVM list, whatever that beta 5 version was, I didn't have it on here anymore. So I don't have that version of the DNX. That's why I got that error. So you may or may not hit that. If you're only ever using released bids, you won't hit it. If you ever start jumping into nightlies like I do, you'll probably start to hit stuff like that all the time. And now I have no faith that Visual Studio is doing what it was supposed to be doing, so I'm going to restart it, but I don't actually know if that's necessary. So I'm going to say Hello Starter Web. What this is file new, preview, in the preview parts of your templates, the Starter Web template. That's what this is. Now, inside it, the reason that I'm jumping over to this is because inside its project JSON, inside its startup CS, it has some interesting things. What it has is it has some configuration set up. So the thing about our configuration system, this causes a bunch of confusion, so I'll really quickly touch on it. The first thing it's doing here is saying add me a config.json. And the next thing it's doing is saying add me a config.environmentName.json. Okay? And then it's saying if I'm in development mode, add something secret. All right? So baked into the iApplication environment, the iHosting environment, sorry, because I had that wrong, is this thing called environment, which is a string. Now, that is powered off of that is the value. There is an environment variable called DNX_environment. Whatever the value of that environment variable is, that's what this thing here will return. If there isn't one, it should be production. Okay? So when you're on your dev machine and you install Visual Studio is going to make sure that that thing is set on your dev machine and it says development. So you always get the development path in here. That means, well now let's see what this means. Oh, down here at the end we add environment variables. So with our configuration system, it's key value pairs, string. You can say config.get and ask it for a key and it'll give you back a value, a string. And when we register our stuff this way, what's going to happen is, if you say, so logically, I guess, it's not quite true because we pre-cache things and stuff, but logically what's happening is if you say config.get foo key or something, or yeah, then it's going to say, is there an environment variable called foo key? No, okay. Is there in this case, if I'm in development, is there some magic secret called foo key? Maybe there is. And then it's going to say, is there a config file like config.development.json file that has that key in it? If yes, it'll return it. And then it'll say, oh, is it in the config.json? Yeah, you get where I'm going with this, hopefully. I went all the way through, I think. So basically, this is the way you set up, and it kind of all merges, and you end up with one big list of key value pairs, right? And the last one wins. So with this exact config setup, if you have your app, and it has a config.json, and inside that it has this connection string for entity framework, and it's in a config.json, and you have a config.development.json, that's the config, and it has this in it with a different connection string, that's the connection string that's going to get used. Unless you're in production, and then it's going to be like config.production.json. If you have an environment variable, and what we do here is by convention in the JSON file, we have data, default connection string, connection string. If you set an environment variable called data, this is a bad place to do this, so default connection, colon, connection string. If you set an environment variable called that, it will override this connection string in the environment. So you can put the production environment, the production connection string in the production environment and nowhere else if you want to do that. So you say to your IT guy, I want you to put the connection string, you make an environment variable on the server, however it gets there, I don't care, it's got to have the connection string in it, and you don't need to tell me, I'll tell you at the end. Okay? So that's how you can have the environment variables override config files. There's also an XML configuration source, and on .NET 4.5 at least, that XML file could be an encrypted XML file, the same as using the encrypted XML standard. The types that need aren't in Core CLR yet, so it only works on 4.5x for now. Eventually it'll work on both and we'll be good. So you could use a certificate to encrypt an XML file and grab keys off that, things like that. Okay, now the other thing though that we're going to talk about here is this user secrets. It's secret and special. What user secrets is for you to put secrets. However, it's not about protecting said secrets. Add user secrets is about adding secret information specific to the user, in this case in your development environment. What I'm talking about is your OAuth key token, your OAuth secret ID, and application ID, right? That's what I'm talking about, stuff like that. Now, you want to go get one of those, you want to put them somewhere on a file in your user profile. You definitely don't want to check them into GitHub or somewhere. GitHub had to turn off their code search feature when they first released it because suddenly everybody could search for key : and find everybody's keys. It was great. So don't check them in because they're secret. Okay? So you don't want everybody knowing what they are. I'm sure there's a lot of you who are like, oh, my source control is completely protected, I can check them in. Fine. If that's what you want to do, go for it. It's still a very bad idea. Don't check them in. Okay, one of our charters from my boss, Scott Hunter, was, for the love of God, make a stack where people aren't encouraged to check secrets into source control. So we're going to try and do that. It was important enough that the engineering teams at Microsoft told every single developer to go to a training session. So you imagine every C&E developer sitting in a room for hours listening to a person telling them not to check in secrets and why it's a bad idea and how much money that would have cost for all of those guys' salaries. That's how important it is to us. So, don't check secrets in. What this add user secrets does is there's a file on disk. It's in your user profile, and you can put stuff in it. We deliberately make it hard for you to find what the file is. And by make it hard, I mean it's documented on the wiki, but that's all. Yeah. So, how do you do it then if you're supposed to be hard, how do I add stuff to it? And you do that via this user-secret command. Okay? So when you're in an app, not in this app because this is the wrong app, but when you're in an app that has some secrets in it, if you go user-secret and you go list, it'll tell you if there's any secrets. Oh, don't I have any project JSONs in here? Oh, I'm one folder short. I can go user-secret. There is none, because I don't have anything secret. And I can use this thing to add them as well. Like you can see here, you can add stuff to that secret hidden file. The thing about this is, you don't have user secret by default. Okay? If you just type user secret after installing Visual Studio as Pro, I don't think it's there. How I got user secret was I went DNU, which is our utility for downloading packages and packaging our application, commands, install secret manager. Now, you've seen this output before, right? Probably, when you do package restore. What this did is it went to NuGet, it downloaded a NuGet package. Inside that NuGet package is an application. It put that application in my user profile, and it wrote a batch file out to disk that I can now run that's on my path. It didn't do anything here because I've already got it on my machine. You just saw it. So, if I open up this bin folder, this is in the same place as where the DNX runtimes are. It's where the DNVM commands and everything are inside your app. It's on the path, otherwise you wouldn't be able to do DNVM or DNU probably. There's a user secrets batch file, like a CMD file. There's a packages folder. This is where Secret Manager and all of its dependencies are. And it has an app. It's an app. It's a DNX-based application. It's not a web application. It's actually running on top of application host, but not on top of hosting. You remember in our stack diagram? So, I can create a DNX application. I can publish it to NuGet. That string, Secret Manager, isn't special. It's just the name of the package that was published. And our DNU will go to NuGet, grab it, download it, put it in somebody's user profile, and put a thing on the path so that they can run it. Fantastic. Okay, so I can create console applications effectively. I can publish them to NuGet. I can get them onto my machine, and I can run them. That's how we did hiding the magic secret file, which is absolutely not in your user profile roaming. Okay, user secrets. Now, I'm pretty sure that is about 2 minutes until the end of this talk. So thank you very, very much for attending. I hope that this was worth delaying some of you. And I thank you very much for coming and attending the talk.